Hello everyone, you are all welcome to lecture number 1246, and today's topic is the properties and structure of pyridine. And previous lecture I have already discussed about the pyridine and its some of the important chemistry, and today I will be discussing the real property of pyridine. And pyridine is very important 6-membered heterocyclic compound, and it plays very important role in industries as a solvent and also in most of the laboratories also. This is one of the best organic solvent. And here the very interesting thing is that the pyridine 6-member heterocyclic compound is more basic as compared to pyrrole, but the aliphatic amines, they are more basic. So here we have to understand the role of electron pair in p orbital of nitrogen. And let me show you the condition is, for example, this is your pyridine. This is pyridine, and this is your pyrrole, and this is your aliphatic amine. So these three compounds are there, and in all these three compounds nitrogen is there, and nitrogen is carrying the pair of electron, and that pair of electron is going to play very important role to determine its basicity, acidic character, and also electrophilic and nucleophilic substitution reaction. And pyridine is very stable basic organic compound of 6-member heterocyclic. It is more basic as compared to pyrrole, and aliphatic amine is more basic as compared to pyrrole and pyridine. So the reason is that in the case of pyridine, it has 6 pi electron delocalized, but the pair of electron is not the part of delocalization. This is very important factor. That's why pyridine is more basic as compared to pyrrole. Reason is that the pair of electron is not the part of delocalization. It is very easily available to share, and once it is very easily available, means its basic character will be more. In the case of pyrrole, this pair of electron which is sitting over nitrogen becomes the part of delocalization. So that's why this electron is not very easily available to share, to go to form the reaction. It's difficult to get. Reason is that it is the part of delocalization, part of resonance. But in pyridine, the pair of electron of nitrogen is not part of resonance, is very easily available. So that's why pyridine is more basic in character, and it is less basic. But if you come to aliphatic means there is no delocalization of electron, no resonance, and the same electron which is present here, it is very, very easy to share with other atom. So that's why aliphatic amine is strong base as compared to these two. Now, this pyridine molecule undergoes substitution reaction. It can be electrophilic substitution or nucleophilic substitution rather than addition reaction. The reason is that these three bonds which we are shown here, they are not actually the original double bond, rather than in betweens, because the 6 pi electrons are delocalized, are moving. So this is delocalized pi electron. So and this delocalization means if it is double bond, means the bond angle should have been 120 degree. If it is double bond, the bond angle should have been 120 degree, or if it is tetrahedral single bond, then it would have been 109.5. So neither it is 120 nor 105, but it is in between bond angle 136 degree. So it shows that it is neither double bond nor single bond, but in between, and that is delocalization. That is the reason. That's why the pyridine molecule is more stable, and also these three sets of sextet electron, they are not in the form of original double bond, rather than they are delocalized. This undergoes hydrogenation in presence of nickel, and you will get pyrimidine, and pyrimidine is aliphatic in nature, and also it can form salt with acid. So all these reactions I am going to show one by one, but before that I am going to show the orbital picture of this pyridine. This is very clear orbital picture of electron, and here you can see the two electrons which is present in the p orbital of nitrogen and is freely available, is not part of resonance or delocalization. That's why benzene is a strong base as compared to pyrrole. So this is the orbital picture of pyridine, where one of the carbon is replaced by nitrogen, and that nitrogen is having extra one pair of electron available for the bond formation, and that's why it is strong base as compared to other 5-member ring. And this is the orbital picture of benzene, where carbon is not having any pair of electron available. That's why benzene is not having basic character, because freely availability of pair of electron is not there in the case of delocalized system of benzene. So here the properties and structure is given, and in the case of pyridine, I have already told you that it is 6-member heterocyclic, and where nitrogen is having lone pair of electron, which is not the part of resonance, and the formula of pyridine is C5H5N, and then it forms salt with acid. Once it is treated with C5H5N, that is pyridine, plus hydrochloric acid, and you will get a C5H5N HCl, that is called pyridine hydrochloride. So this reaction shows that it is basic in character. Number 2, pyridine undergoes catalytic hydrogenation to form piperidine, and piperidine, PIPRIDINE, piperidine, that is C5H11N, or we can write like this. Once it is saturated, it will be like this. That is your pyridine. Then come to third resonance picture. Here I have given the resonance hybrid of the pyridine, and here is structure A, and then how the 6 pi electrons are delocalized, and once there is formation of carbonium ion where the minus charge is on nitrogen, and then carbonium is here at 4 position, then at 6 position here D, and how this the carbonyl and carbonium ion, they are delocalized, and the broken line here shows that sextet of delocalized pi electron, and that gives the aromatic character to pyridine, and hence it shows aromatic character and undergoes electrophilic substitution reaction. So here the pyridine is in delocalized form. A positive is electrophile, which is coming to attack, and this is the transition where proton is going to be released, and then electrophile A will be linked to this position 3, and that electron will be shifted to position 4. In this way you will get 3 position stable and 3 substituted derivative. At 3 position or at 5 position, the electrophile is substituted because these positions are stabilized carbonium ion resonance structure. That's why it will not undergo either 2 substituted or 4 substituted rather than 3 and 5 substituted. The reason is that nitrogen is more electronegative, and it will not tolerate positive we can say ion or positive charge sitting side by nitrogen very close on carbon. That's why it is shifted to 3 position rather than 2. This is the main reason. That's why we get 3,5 substituted derivative of pyridine. So here orbital picture of pyridine is given, and it is shown how the sextet 6 pi electrons are delocalized, that is above or below of the hexagonal ring, and that gives the pyridine stable character, and 1 pair of electron is already available at nitrogen. So this is above the ring, the delocalized pi electron, and this is below the ring of this hexagonal pi electron. And nitrogen in pyridine has 3 sp2 hybrid orbitals and an unhybridized p orbital. The hybridized orbitals of carbon atoms, that is 5 carbon and 1 nitrogen, overlap one another sideway to form cyclic O, that is delocalized molecular orbitals. So these hybridized orbitals, they are forming delocalized molecular orbitals containing sextet of pi electrons. These are the sextet of pi electrons, and which are delocalized above and below the ring, and this delocalized pi electron cloud lying above and below the ring. The uses of pyridine. Pyridine, I have already told you, is one of the most powerful, most popular organic solvent, and it is widely used in many pharmaceutical, pesticide, and drug, vitamin producing industries, textile industries. It is very much in use. And one more thing, please, it is my advice, those people who are working in industries, pharmaceutical companies, or any drug or pesticide industries, once you are handling pyridine, please don't bring just in front of your nose. It should be in air exhaust compound type, so that whatever fume is coming out of pyridine, it must escape outside. You should not inhale, because it is so much powerful that if you are inhaling, sometimes your prostate gland and some chemicals can be dissolved, and for long duration of inhaling of pyridine may cause impotency. So it's a very serious matter. It is found that many people who were very much exposed for long duration of time using pyridine solvent, they got the problem of dilation or dilution of their prostate gland molecules, and finally they became impotent and their prostate gland was not properly functioning because of the effect of the pyridine vapor. So it is used as a solvent, mild base in organic reactions. It is one of the best solvent for paint, rubber industries, pharmaceutical industries, in resin industries, textile, water repellent, and also pyridine is used to make products such as vitamins. It is used in food flavoring, herbicide, and in insecticide. So with this, I will stop. Thank you very much for watching the lecture.